were talking about the Big Bang earlier. We're talking about observational evidence. And this is one of the big topics me and Corey and we're really interested in. We wanted to talk about the Big Bang, it's specifically around Hubbles Law, right? And the expanding universe, right? We call it the greatest cosmological discovery of all times, right? And one of the most interesting things about, Hubbles Law, right? It provides one of the biggest pieces of observational evidence that we have that supports the Big Bang theory, right? So let me know if you guys can actually see this, what I'm sharing. Can you guys see this slideshow?
Yeah, you can see it.
Awesome. So we suggested readings here. This is this is a textbook. This is called The Essentials Cosmic Perspective. One thing that's interesting about this particular series is that I actually use this. This was the first astronomy textbook that I used back in my undergraduate studies. This was way back in the 90s, I think, when I was still an undergraduate. Back then, I think it was in its second edition, maybe second or third edition. I currently have the 8th edition of this book, but I think it's even, there's even subsequent editions, right? So if anybody in the chat, right, you guys are really interested in a good, solid collegiate textbook on astronomy, grab The Essential Cosmic Perspective, right? This is something that's been around. It's been used inside of college classrooms for several decades, right? So who is Edwin Hubble, right? So if you guys can actually see this this picture here, this is probably one of the most famous pictures of Edwin Hubble. You see him staring inside of his telescope here, right? At the time, this was the largest telescope on the planet, right? This was his telescope that's sitting in his huge observatory in California, right? When him and his assistant basically spent a ton of hours staring inside the night sky. Right. Again, he's an American astronomer, born 1889, died 1953. Right. One of the interesting things is many scientists or astronomers believe Edwin Hubble would have won the Nobel Prize if he hadn't died in 1953. But again, that's up to interpretation. Right. And one of his, I guess, him and his assistant, one of their biggest first discoveries is that he was able to determine the distance of faraway galaxies. Right. Before then, we didn't know of those small little gassy things that we were observing inside the night sky with his telescope. He didn't know if those were gas clouds. He didn't know if there was galaxies. We didn't know how far away they were. Right. But that was one of his biggest things. Him and his assistant discovered that the Milky Way is one of many galaxies in an enormous and a very large universe, right? Right? Now, in terms of that first discovery, this led the way to one of the subsequent, really, I would say even more significant discoveries, right? Right. So as they didn't stop there, they continued to observe these galaxies inside the night sky. And what they noticed is that light from those very distant galaxies, those spiral galaxies, was redshifted, right? It was shifted towards the red side of the spectrum of the visible spectrum. Now, at the time, scientists knew, right, light was actually subject to the Doppler effect, right? And when they actually observed light that was redshifted, then that was light being emitted from an object that was moving away from them, right? So that lends credence to say, hey, all of this redshifted light from these distant galaxies, right? That means that these galaxies are moving away, right? And through his calculations, right, what he was able to do as well, right, he's able to calculate the more distant the faraway galaxies, the greater the redshift, right? And through his calculations, the greater the redshift, the faster that galaxy was actually moving away from us, right? So that lends credence to the idea, right? They basically discovered that the universe was expanding, right? So in terms of quantifying that, he was actually able to quantify that in what we call the Hubbles Law. So if you see here, right, essentially the Hubbles Law is the recession speed of galaxies. The recession speed is basically the speed at which the faraway galaxy is moving away from us, right? As you can see here, if you guys can see it, it's very simple, small, elegant equation, right? So V is the recession speed, right? This is the recession. This is the speed at which the faraway galaxy is moving away from the observer, right? H naught, right? That's called H naught, right? That is the Hubble's constant. That is the rate in which the universe is actually expanding, right? So the recession speed equals H naught, Hubble's constant, times the distance, right? The distance of the faraway galaxy or the faraway object that's being observed, right? So essentially what this equation is telling us is that that recession speed, right, is proportional to the distance, right, away from the observer, right? So one of the biggest, I guess, questions that we have inside of science today, right? And if you get online, you Google the Hubble's constant, right? How do you actually, calculate the Hubble's constant, right? So that's one of the biggest questions there, right? So currently, in terms of how we're doing it today, right? We're using the Hubble Space Telescope. Of course, you have to have these enormously powerful observational tools, right? And the current best direct measurement that we have for the Hubble's constant is 73.8 kilometers per second per megaparsec, right? So a parsec is essentially, this is how we actually measure astronomical distances inside of the cosmos, right? So a parsec is 3.26 light years, right? And as its name suggests, a megaparsec, right? That's mega is a million, right? So a megaparsec is 3.26 million light years. So that kind of gives you a scale of the distances that we're actually measuring here. And if you can see at the very bottom, I have a reference there. If you guys
sorry, Brendan, but no, it don't.
Right, go to that source, right? In terms of the Hubble's constant, what it is, right? It's and one of the biggest jokes inside of astrophysics and cosmology is that Hubble's constant is everything but constant, right? Right, that it changes over time. So this is one of those big running jokes in terms of that. Let me let Google Scholar in here. All right. So, and again, right, all of this, right, this is very, I guess you would say, relevant to the Big Bang Theory, because this was one in terms of what Hubble was actually able to discover, that this actually started the idea that the universe was expanding, right? And this data, right, is direct observational evidence that supports the Big Bang Theory, right?